Hey guys, this is Miss Howell. You've got the handouts in front of you this week in class, and we're going to use this slide presentation to work through these notes. And we want to see how this works. If it works well, I'm going to send these home with you from now on, and that way we'll have more class time to do things other than work our way through these packets. But for this week, we're going to do it sitting in the classroom and see how it works and get your feedback. So you guys let me know how you think this is going. All right, so we're going to do Module 4B. These are the major types of joints and movement. But at first, we're going to just do a quick flyby review and go through some things that were in Module A, 4A. All right, so far we covered bone histology, which we basically learned that bone is a connective tissue, one of the connective tissues in the body, and that bone is the term osteo. When you see that prefix osteo, we know we're talking about bone. There were three basic types of bone cells that you learned. The osteoblast was the bone forming cell, the osteocyte was a mature bone cell, and the osteoclast was the large bone cell that has more than one nucleus, and it's involved in breaking down bones. You did a lab that you've turned in for me, the lab that you soaked the bones, the chicken bones, in vinegar. You learned a little bit about a term called hydroxyapatite, and you learned that these minerals, calcium and phosphorus, are important for keeping bones hard. If you're missing calcium or phosphorus, then your bones are going to be more brittle or even more rubbery, as you found. So we'll get your labs graded. All right, you also, for review, we learned a little bit last class period before break about the compact versus cancellous bone. Compact bones are made of osteons that are in concentric lamella with interstitial lamella in between, and cancellous or spongy bone is made up of trabeculae that have spaces in between filled with blood vessels and bone marrow. We talked last time about the anatomy of a long bone. I drew that on the board, and we talked about the epiphysis and the diaphysis and where the epiphyseal plate was. We talked about bone growth and repair, and we looked a little bit at the very end, ran out of time a little bit, about hormones like human growth hormone and pituitary growth hormone and the sex hormones and how they're involved necessary in skeletal system and bone growth. All right, so now we're going to move on to the new material. So let's get your packets out and we're going to fill in the blanks. What I want you to do in the videos today and in the future is look for the words that I've put in red, and those are going to be the words that fill in the blank on your packet. And then also look for items that have a star by them. Those are things for this particular unit that are going to help you find your terms and items that you'll need for your test coming up. The next test will be an open note, open book test. All right, remember you can stop and slow down anytime you want to at home. Look for the red words, fill in the blanks. I'm going to go pretty fast because I want to get through this in less than 15 minutes. I've got 12 minutes to go. All right, ready? So here we go. A joint is a place where bones are held together, and there are three major types of joints: the fibrous, cartilaginous, and synovial. A fibrous joint consists of two bones that are joined together by fibrous connective tissue. These joints are immovable or only slightly movable. This type of joint can be further classified as a suture or a syndesmosis. A suture is completely immovable and it's only found in the skull. A syndesmosis is a fibrous connection between two bones that are further away from each other than those of the skull. The example is the radius and the ulna that are connected by fibrous tissue, making this joint slightly movable. Cartilaginous joints are the points at which bones are connected with fibrocartilage or hyaline cartilage. These joints are also immovable or slightly movable, and this joint can be further classified as synchondrosis or symphysis. A synchondroses are consisting of joints that are made by hyaline cartilage, the epiphyseal plate in immature bone, and the cartilage that joins the ribs in the sternum are examples. A symphysis consists of bones that are joined by fibrocartilage. This type of joint is found in the symphysis pubis and the intervertebral discs between the bone and the vertebral column. The third type of joint is the synovial joint. Notice the star. This type of joint contains synovial fluid, and it's efficient at allowing movement. There are 6 different kinds of synovial joints. We'll get to those in a few minutes. In this type of joint, the ends of the bone are covered with articular cartilage, which is made from hyaline cartilage. This cartilage helps the bones move in a joint without damaging the bones. The bones move against each other, normally causing friction that can slow down movement and produce heat. To get around that problem, the joint is surrounded by articular capsule, and this capsule is made up of 2 layers. The outermost layer is called the fibrous capsule, and it's made from dense, irregular connective tissue. It's usually an extension of the outer layer of the periosteum. This holds the bones together in the joint, and if the articular capsule extends beyond the joint, this is called a bursa. The bursa is a fluid-filled cushion between bone and bone, bone and tendon, or tendon and tendon, and it prevents these structures from rubbing against each other. The term bursitis, it just means inflammation of that bursa, or fluid-filled sac. The inner layer of the articular capsule is called the synovial membrane. This membrane has cells in it which produce synovial fluid. The fluid is made from blood plasma and other chemicals like proteins, fats, and polysaccharides. One of the polysaccharides is called hyaluronic acid. This is what makes the synovial fluid very slippery and lubricates the joints. There are 6 different types of synovial joints I told you before, and here they are. We've got the ball and socket, which gives us our highest range of motion. This type of joint is composed of a rounded head or the ball on the end of a bone, which rests in a rounded depression or socket on the other end of the joint. It's designed for movement in all directions, and the example given is the hip and the shoulder. The next one is the hinge. Gives us motion in only one plane. This type of joint is composed of a cylinder at one end resting in a cylindrical depression at the other end, designed for movement of one direction, like the knee and the elbow. An example is when you squat down, your knee bends. The next one is a saddle joint. Has a larger ROM, which means range of motion, than a hinge, but not as great as a ball and socket. It does not allow for rotation. This type of joint is composed of 2 saddle-shaped bones that are oriented perpendicular to each other. An example is the joint that joins your thumb's carpal to the metacarpal. That's a saddle joint. The next one is ellipsoid. That's similar to the ball and socket shape, but it's elliptical instead of round. The range of motion, or ROM, is more limited than the ball and socket. It allows for slight rotation similar to the saddle joint. The example is a wrist. The next one is a pivot, which is partial range of motion or partial rotational motion. This type of joint is formed when a process from one bone is surrounded by the ring of another bone. The example given is the second cervical vertebrae in your neck has a long process that pokes through the foramen, or the circle of the first cervical vertebrae. This forms a pivot joint, allowing you to rotate your head and shake your head no. The next one is a plane joint, also called a gliding joint. Note the star. There is very little motion here. It consists of 2 flat surfaces of equal size, roughly, which slide against one another. An example is a process from your scapula, or your shoulder blade, rubs against a process in the clavicle, or the collarbone, which makes this a gliding joint. The joint between the superior articular process of one vertebrae and the inferior articular process of another, where your vertebrae stack together, is another example. And generally, the more range of motion in a joint, the less stable it is. The less range of motion it's able to do, the more stable it is. All right, moving on to motion in terms of movement. First red word here, anatomical position. That's the position acquired when one stands erect with your feet facing forward, your upper limbs are hanging at your side with your palms facing forward, the thumbs to the outside. All right, in that position, superior means above, inferior means below, And these two terms are only referencing the head, the neck, and the trunk. If we're talking about your limbs, like your arms and legs, we use terms proximal to mean more near and distal to mean more far away or distant. Anterior means the front and posterior means the back. Midline is the imaginary line that runs down the center of your body, separating the right from the left. A plane running down the body in the midline is called the mid-sagittal plane, which divides your body into two equal halves, right and left. The term midline can refer to a line running down the middle of any structure. If a part of the body is located away from midline, we say that it is lateral. If the part of the body is located close to the midline, we say it is medial. All right, moving on. These terms have to do with movement, and we'll move from there. Okay, extension means to straighten a joint. So if I extend my arm, I've straightened out my arm. Flexion, here you are decreasing an angle between the bone of the joint. So when you're squatting down, you're decreasing the angle of your femur and your tibia. That's a flexion movement. Also, flexing your biceps pulls your radial and ulna bones towards the humerus bone. So that's a flexion. Plantar flexion is moving the ankle so that you can stand on your toes. So if you get up on the balls of your feet, you're plantar flexing. Dorsiflexion is moving the ankle so that the angle between the foot and the tibia decreases. So if I'm standing up on my feet and I lift my toe up in the air and I put my weight on my heels and my toes are up, that's dorsiflexion. Abduction, joints moving the bone away from midline. So if I'm pulling my leg away from midline, that's abduction. Adduction moves the bones back toward the midline. Inversion is turning the foot inward. Eversion turns the foot outward. Circumduction is a circular motion performed by the ball and socket joint. Rotation occurs when a joint turns a bone on its axis. If it's moving toward the midline, that's medial rotation. If I'm rotating away from midline, that's lateral rotation. Supination is rotating your forearm so that your palm faces up, superior, or anterior toward the front. Pronation is rotating your forearm so that the palm faces inferior or down, or posterior towards the back. And usually you say a person is laying prone if they're face down, and they're supine if they're laying face up. All right, and when we come to class, the next time, if this was something that you had done at home, we would have spent time in class actually moving our body in all these different directions, and we may do that if we have time. All right, so hopefully this will help. Go back and replay this at home. I'm going to send this out to you. In the future, these will always be sent to you, and your worksheets will be given to you to work on at home. I'll send them by email or hand them to you in class, and you'll have that completed on your own, and then we'll be able to talk more in class and do more fun things in class, because I think doing this in class, just filling in the blanks, has been driving me crazy, and it's probably driving you crazy too. Thanks a lot. Bye.